All right. Hope you had a good weekend. We're going to continue using Excel today for some things, but we'll also circle back to reinforce the old style table method for solving present worth. Your next assignment's due in 2 days. Homework 3 should be submitted before class on Wednesday. And where you solve hand calculations, please scan that as a single continuous PDF file. Remember that it should be scanned either as black and white or grayscale. And then, and the reason for that is to improve the contrast and the clarity of the photo that's being turned into a PDF. And then the other thing about it is please don't use line notebook paper or graph paper because that just makes it really visually distracting and harder to see what you've actually written. So either use engineering computation paper or just blank copy paper for your hand calculations. Now, if you use Excel for a problem, please include the Excel file, not just a PDF of the Excel file. So the Excel file itself should be uploaded, and the reason for that is if you've made a mistake, then the grader would need the Excel file itself to get in and see what your formulas were and offer some suggestions. Where if it's just a printout of the spreadsheet, then it's not possible to get in and see what your formulas were. So, any questions about homework number 3? All right.
Quick.
Yeah.
Do you want every problem on one Excel file?
That's a good question. Yeah, so the best way to do it, in my opinion, is each problem should be its own tab. So, you know, when you've got a workbook, it creates sheet 1 here, so then this is problem 1, blah, blah, blah. You do problem 1. Then you create a different sheet, and you could even name this P1. And you create another sheet. Here's P2. Title it at the top, problem 2. Then, you know, maybe problem 3 you do by hand, so then it's problem 4 that you're doing with the spreadsheet. Problem 4. Does that answer your question? Yeah. Thanks for asking that. That's a good question. That's my suggestion. If you don't want to do it that way, you know, find another way to make it clear to the grader how you're breaking up which problem is solved in the space here. The grader's job is not to go hunting for your answer. You need to communicate your solution in a very clear and obvious way. So bolding the answer, highlighting it in yellow, anything you can do to signpost how you did your work and what the solution is, that'll really improve your chance of getting full credit on the problem. Are there other questions related to homework 3? Okay. Now, let's just review what we do when we have a complicated cash flow diagram like this. So what makes it complicated is the fact that we can't solve for the final answer in a single step. If we wanted to know the present worth, so we want to discount all of these future values to times 0, then it's going to be several steps along the way. So the strategy for that, my suggestion is before you get out your calculator and start crunching numbers, what you ought to do is just lay out in some conceptual shorthand which calculations you're going to perform before you actually do the calculations. So just for instance, you might say, my step 1 is to take this money that's in years 2 through 4 to time 1. So you'd say maybe, you know, step 1, take the A at years 2 through 4 to year 1 with P/A. So this is just kind of like summarizing what your approach is going to be. And then you might say, all right, and then after I do that, it's in year 1, but I want that amount to be at the present, which is times 0. So my next step would be, for step 2, take the lump sum at year 1 to year 0 with find P given F. Okay, so we've got now all of the inflows to times 0, and now we have to discount the outflows to times 0. So what are we looking at with this series of outflows? Anybody recognize the two parts of this series?
An annual series and a gradient.
Very good. It's a gradient on top of an annual series. So the annual series, A equals 5,000, and the gradient, G, equals 1,000. So our steps might be to first take the annual series. So step 3 would be take A at years 7 through 10 to year 6 using find P given A. And then we get a single lump sum from that at year 6. And the next thing would be discounting the gradient to year 6 as well. So then step 4, take G at years 7 through 10 to year 6 using find P given G. Now remember that year 7 is 0G, so we don't see the effect of the gradient until the second year after the quasi-present, which is year 6. And so this is all good. I'm just reminding you that you don't see the effect of the gradient until 2 years after the present, whereas the annual series you see kicking in 1 year after the present. Okay, so now we've got all of this lump sum amount at year 6, and our final step would be to discount it to the present. So take the lump sum at year 6 to year 0 using find P given F. So if you were doing the table method, now that you've got this all laid out, what you could do is say, well, I know I want to do a find P given A with I equals, and 8%, N equals 3. So you could look up that factor, and then you could just basically translate your strategy into the factors that you're going to need. Find P given F, I equals 8%, N equals 1, and then, like, what is that factor that you're going to use to multiply by the amounts? So do it kind of like in sequence. Map out the strategy, then find the factors, and then pull out your calculator and start actually calculating the amounts themselves. Yes?
So just to be clear about the gradient, so it's going to year 6, but would the value for G be 1,000?
Yes. G is 1,000. N equals 1, 2, 3, 4, even though we only see that 1,000 kicking in 3 different times. Yeah, that's just the strange convention of gradients. But yes, you're right. G is 1,000, N equals 4, and we're taking it all to year 6 as a lump sum. Good question. Are there others? Other questions? Strategy. All right, I want you to do some strategy. Let me, this is the first problem of your in-class exercise, and here I've solved it for you. I better erase it really quickly. All right. I want you, now that you've seen the answer, hopefully you remember some of that. And so let me give you the paper for this. I didn't actually find the factors or the numbers. I showed you the strategy, but you're going to have to practice writing that out again. Okay, so what I just did on the board, you do that in kind of your own words, in whatever shorthand or notation you think is clever, is good for you. And then on the back side of the paper is the 8% table. So the step that I didn't do is actually look up what are the factors and what are the values. I want to know what is the sum of the present values for this cash flow diagram. So it's going to have several different pieces here, several different steps. Let's take, I think it'll probably be a 15-minute problem for you to calculate what is the present value for this cash flow diagram. Maybe faster, but so you can see I've kind of sketched out and labeled these arrows. And I'm calling, for example, this lump sum at year 1, I'm calling that A, just to make it clear that, you know, this 28,348 is some amount that's corresponding to arrow A on the diagram. So my first step was to take the repeating 11,000 from years 2 through 4 into a single amount at year 1. Should be 28,348 and 10 cents. I'll round off at the very end. So for now, I'm ignoring the fact that I only have 1, 2, 3, 4, 5 digits of precision. So I'll leave this as though it was more precise, and then at the end I'll round off. So step 2, then you discount that lump sum from A in year 1 to the present at time 0. So this is a revenue of $26,247. That means it's a positive value. All of the amounts on the underside of the cash flow diagram represent outflows, and so when I combine them at the very end, I should subtract the two amounts. So this is an inflow. Now, the bottom half of the cash flow diagram is a little more complicated. You can see I've labeled it as here's 0G, 1G, 2G, 3G, just to kind of remind myself of the form of a gradient. And so the first thing I did was I took the annual series and turned it into this arrow, which I'm labeling as arrow C. And that should be negative 16,560. And then the gradient part of it is being discounted to this lump sum that I'm calling arrow D. And so arrow D has a value of 4650 as an outflow, so minus sign there. And then I need to discount the combined amount at year 6 to times 0. So that'll be find P given F. So the sum total of the present values is an inflow of 26,247, an outflow of 13,366, and so the minus sign takes care of the fact that one of those is an outflow. And the present value, if you round off now to 4 digits, because a couple of the factors in here only had 4 digits of precision. So the find P given F factor only had 4 digits, and so I round off the final answer to the nearest $10. So 12,880. Does anybody have questions about this one?
I
Yeah.
have a question kind of just related. So, like on homework that involves problems like this, is it okay if we account for the loss of precision in each of the steps, or would you want us to just round it all off at the end?
That's a good question. In this class, it won't matter as much as some of your others. If you round off during intermediate steps, the imprecision can compound in some classes, especially if we're talking about like exponential functions. So I think it's just a good habit to round off at the end rather than in between.
Okay.
It's not something probably you're going to get points taken off from, but just from kind of like a engineering hygiene perspective, it's best if you round off at the very end one time. So that's a good question. And by the way, you get the same answer if you did the outflows first and then the inflows. So for a lot of these, it's not like there's a single right way to do it. There's multiple approaches. And so as long as you get the right answer and your solution is clear, then it doesn't matter if you did the outflows first or the inflows. And a lot of these multi-step problems are going to have multiple ways of doing it, and that's okay. The one way I would be disappointed, I'd be disappointed if all you did was repeated find P given F 1, 2, 3, 4, 5, 6, 7 times. I'd think that was a little bit inelegant. I'd think that was kind of like the lunk way of doing it. So, but anyways, any questions about this first one? All right, so the second problem. Let me pull up the second problem so that it's recorded in the lecture. Actually, it might be as a slide. This. All right, find the future value in year 16 for this cash flow diagram. And you'll remember that when we set something up as a regular cash flow table, like just as a proof, I solved the first problem as a cash flow table to show you get the same amount. So on paper, when we solved this one, our paper answer was 12,880. So if we solve it using Excel, we also get 12,880 roughly. You know, this was with full precision, it should be 12,881 and 85 cents. But the broader point is that when you're finding present values, then your columns are year, amount, and then present value of amount. But in this second problem that you've got in today's in-class exercise, I'm asking you to find the future value. So remember, when you do the FV function, and we looked at this on Friday, when you do the FV function, NPER isn't what row are you on. It's not which year is it. NPER means what is the number of periods into the future that you need to compound that amount. So here in the suggested column titles, I'm saying you should have one of your columns say year, another one be kind of a reverse time column, where it's how many years is it from that year until year 16, which is the frame of reference we want to take all the money to. Then the amount as it appears on the cash flow table, and then finally the calculated FV of the amount. A couple of reminders. Number one, you need to anchor the reference to the interest rate by putting in the dollar signs. Otherwise, when you drag the formula down, it's not going to work correctly. And then the other reminder is remember to put in the minus sign in the amount, because Excel always flops the sign. If you give it an inflow, it'll give you an outflow. So you need to manually account for that by putting the minus sign. All right, so let me give you a moment to translate this cash flow diagram into a cash flow table, calculate the FV in year 16. I'm going to start working through the solution to the second problem. Okay, so part A was find out what is the net value of the following cash flow diagram in year 16. So 61,157 and 18 cents. If we compound all of those amounts to year 16, the equivalent value, and what that means as equivalent is like if instead of getting and paying this money over time, what if you just wanted to have a single payment that was economically equivalent at this interest rate? It would be this 61,157. So part B says, let's play around with the interest rate to find out what would the interest rate need to be to make this amount 100,000. So I'm going to create a copy down here. So let me delete these earlier pages, and I'm going to call this in-class exercise 9, problem 2, part A. Okay, and I can right-click on it. Watch this. If you right-click on the tab and move or copy, let's create a copy and move it to the end. So now, you see here is an exact duplicate, but I'm just going to rename this one part B, and then play around with this interest rate until that equals 100,000. So is it 7%? Getting closer. 8%? 9%? And you'll remember maybe that there's this goal seek tool where we don't have to manually do it. We can do data, what if analysis, goal seek, and our approach is that we want to set this equal to 100,000 by changing the interest rate. And as soon as we click OK, it's going to play around with a lot of different values for the interest rate until it finds one that makes the target cell equal to 100,000. All right, so now our answer would be a little bit different. The answer is the interest rate that makes the future value equal to 100,000 is 17.25%. Okay, so if this is a homework problem, I'd make that in bold because this is my answer, and I guess it would be okay to leave this bold, but I wouldn't necessarily make it highlighted anymore because that's 100,000 isn't the final answer. The final answer is what's the interest rate? And the answer is 17.25%. Anybody else get the same 17.25% who had worked ahead on that one? Good. We still have 3 minutes to do the last problem. The last problem gives us a table and asks us to try the rate function. So rate is something that can tell us what is the interest rate that brings equilibrium between the inflow and the outflow. I may have showed you the rate function already. I don't recall, honestly. But let's work through this because it's easy. The cash flow diagram is here. Let me paste it so that I have it visible as I set up my calculations. Okay, so year, amount, so year 0 down through 7. We still got loads of time here. 2 minutes is an eternity with Excel. Minus 45, 460, and 7,500. All right. So the rate function equals rate, and it starts to give me hints. NPER. Okay. I can either type in the number or click on the references. So 7 is the number of periods. The payment that recurs multiple times is 7,500. And the present value, lump sum, minus 45,460, close parentheses, and it's going to find out what is the interest rate that brings the inflows and the outflows into equilibrium. It should be 3.73%. So that would be the interest rate that is your rate of return. if you made a purchase of some equipment at year 0 and paid $45,460, and then you had the stream of revenue across 7 years. This rate that we just solved for brings balance. Remember the elephant standing on the beach ball? Balance means that the inflows and the outflows are equal to each other when everything is discounted to the same time frame at the unknown interest rate. So that's it for today. Let me just remind you that the homework assignment is due on Wednesday, so please have it uploaded to Blackboard before class, and let me know if you've got any questions. See you Wednesday.